All right, we're back for Swyk 2. More review. Getting into more of this division stuff. We're going to be doing. So remember, you divide the coefficients, but of course, we got a 1 on the top and a 1 on the bottom. That's pretty boring, so that's going to be just 1. Subtracting the exponents, 180 minus 20, and 90 minus 45. That's what gives us these two exponents. Nothing earth-shattering there. I also wanted to show you that when you do division like this, you can separate things, right? We can think of this as 22 over 11 times x to the 6th over x to the 2nd. You can really look at it as two separate fractions. And then once we figure out those things, we can put them back together at the end. 22 over 11 is obviously 2. Subtracting 6 minus 2 is 4. Nothing horribly difficult there. I know this is going to be a lot of review for you. Same thing here. Now, do I always, write it in two separate fractions? No, but I do want you to be able to see that in case it's more helpful to you. Some people it's more helpful than others. Negative 60 over 15 is obviously negative 4 because 15 goes into 64 times. And then you can subtract the exponents. So there's your final answer on that one. Question 15. If you do separate it, remember that you can take a 12 out of the top and the bottom, but that's going to leave you negative 1 on the top, 2 on the bottom. That's negative 1/2. And then you could separate so you got 16, take away 6, that's x to the 10th. Notice that 9 minus 9 gives you 0. Remember, what is y to the 0? Remember, that is 1. Anything to the 0 power is 1. Another way to say that is the same thing on the top and bottom, and that's how you end up with a 1. Well, we're not going to write that, because we know it's times 1. Anything can be multiplied by 1. Question 16. So now we're getting into the power of a power for a fraction, right? You're going to distribute the exponent on the outside. Both of the exponents on the inside, they were 1s, but now we're squaring that. We're multiplying by 2 on those exponents. Another way to say that would be x to the 5th times x to the 5th. If that's, oops, x to the 5th, x over 5. What am I doing? Okay, let me erase this. So that's where we would get x squared on the top, 25 on the bottom. Remember, when you multiply fractions, you go straight across the top and straight across the bottom. Another way to say that would be, so either x squared over 25 or 1 over 25 x squared would be another way to say that. Similar situation here, just more practice. You got 4 times 6, 4 times 1. So that's x to the 24th on the top, 5 to the 4th on the bottom, which is 625. I mean, you can write it like this, or you can write it like this. It doesn't matter. As long as you understand that division is the same as multiplying by the reciprocal, and the reciprocal of 625 would be 1 over 625. Question 18. Similar, right? Every exponent on the inside is getting multiplied. So that's negative 3 to the 4th. Now you'll notice I put that in parentheses. I want you to understand that when you take negative numbers and raise them to a power, it's important that you use those parentheses, especially if you're trying to simplify it on a calculator. But you should realize that's going to be a positive number, right? Because you have an even number of negative signs. So that's 81. You got a to the 24th and b to the 12th. There's nothing that can be simplified there because there's no common bases, if that's what you're wondering. Okay, a couple small equations for you to solve that involve these kinds of properties. How do we get rid of multiplication? Of course, we divide. And when we divide by r squared, we have r to the 7th over r squared. Well, we subtract the exponents. And that's how we know that x is equal to 5. On question 20, there's actually kind of two different ways you could think about question 20. One, you could think about it as taking a 5th root of both sides. 5 goes into 40 8 times. That's a concept we'll kind of get into in the next assignment, next Swyk, or coming up later this week. Another way to look at it is like this. You started out with this on the left side. We could rewrite 40 as r to the 8th raised to the 5th power. And then you can kind of match up and say, well, these are both 5s, right? So that means that x has to be 8. That's another way to look at it. And I think we got one more question. So this one would also be division, right? Divide by that r to the fifth, kind of like we did with the r squared in the number 19. But then we have 1 divided by r to the fifth. 1 divided by r to the fifth. Now, remember, we talked about this a little bit. Anything to the 0 power is equal to 1. So you'll notice that I replaced 1 with r to the 0. So we have r to the 0 on the top, r to the fifth on the bottom. And then we talked about what do you do with those exponents? We subtract them, right? Well, when we subtract them, we get r to the negative fifth. So that means that that exponent, right, that exponent which was the one we're looking for, is really negative 5. So, hope that helps you as you get ready for assignment number 1.